I'm going to start
Yeah.
broadcasting. And there's, okay, so we've got 13 people so far.
Great.
All right, guys, as you come in, if you just want to say hi and where you're joining us from, that'd be awesome. So unfortunately, Favio is sick today, and he's very sad to miss this, because if you've been with us for a while, you know that Favio he's been here for every single one. So he sends his love from bed. Hi, Anderson from New York. Hi, Mohana. How's it going? All right, so we'll give people a couple more minutes to join. History Rom. Hi, okay, Algeria. Hi, Mohammed. Hi, Will. Kumar from Bangalore. Hello. Okay, so I think we can jump right in because we have a lot that we want to talk about today, and I'm super excited. However, I've seen you all over the internet, and I've read your blogs. But when we were on before we went live, I didn't ask how to pronounce your name, and I don't want to give it a try. So why don't you introduce yourself? Tell us a little bit about your background and sort of all the way. Like, where did you start? Where are you now? And sort of what are the big things that you're involved in at the moment?
Sure. Yeah. So yeah, I'm Dipanjan, and yeah, people call me DJ also. That's easier to pronounce, as you might know. And right now, I recently joined Red Hat as a data scientist, as you might be knowing. Many of you may not be knowing because I haven't yet publicly disclosed it, but I recently joined them. Yeah, thanks. As a data scientist, and yeah, I mean, primarily I used to work as a data scientist at Intel before this. I used to focus on various areas like trying to solve real-world business problems across different verticals, be it in infrastructure, in supply chain, different aspects, and basically working on real data and applying data science on that. Besides working as a data scientist, I love sharing stuff with the community and even help people learn data science. So I've worked with organizations like Springboard, where I help people ramp up on data science, even help them design their own course curriculum. And I'm also an author. I've written several books around data science, machine learning, NLP, deep learning. I'm also an editor at Towards Data Science. Many of you might be knowing it's a pretty good online publication where a lot of people come in and write some good content around AI, data science, deep learning, ML, right? And I work as an editor there, so we make sure good content is coming out to you guys because, yeah, we get a lot of posts. And I occasionally write some nice articles, blogs, which surprisingly, so far, I've gotten great feedback around. So, yep, that is me in a nutshell.
Awesome, awesome. So I actually had interviewed for Red Hat as well, because there happens to be a Red Hat like 10 minutes from my house. And then I got an offer quicker from Constant Contact. So I'm commuting, and every day on the long drive, I'm like, oh, maybe I should have waited a bit. I don't know. No, I mean, I love my job, but Red Hat's literally like 10 minutes from me. And yeah, so very, yeah. Yeah, and I also publish on Towards Data Science. So yeah, definitely love that publication. It's awesome. Okay, so the focus today was on skills, and so DJ thought that a good way to sort of open it up would be to show the Harvard Business Review. Here, can I click on this? So
yeah, the HBR Data Science Quadrant, I think.
Yeah. So I have this up.
Oh, yeah.
I can't get the full screen, but this is good. No, that's
Yeah,
to
I think it's
schedule it.
visible. So,
Yeah,
yep.
totally, totally, totally. And so what was your first thought when you saw this?
Yeah, so the idea is we know there is a lot of things out there to learn for data scientists. And when I read this article, surprisingly, yes, I read it based on what people had shared based on their unbiased opinions, surprisingly. And my first thought was obviously looks like people who think what are the skills necessary for data scientists. No one knows it except data scientists. That was my first thought when I saw
Mhm.
this. But when I read it, I read the article in more detail. Looks like this wasn't done by Harvard Business Review, but more by people from a specific company. And just that, based on the comments which I read, looked like Harvard Business Review didn't really do the right reviewing before publishing it, which maybe they should have done, because this quadrant honestly looks very poorly designed in my opinion. Because if you look at things like math or stats, these are basic foundational skills which a data scientist kind of needs to build upon to do everything else, right? I mean, you can't really do data visualization without knowing statistics, in my opinion. Or let's take business intelligence, right? One of the key foundational pillars of, I would say, the industry today, right, for business to really thrive on, because any enterprise really leverages, I think 70% of the success comes from BI right now. I mean, we are getting there with predictive analytics and everything else, but BI is really important, and without math and stats, there is no BI. So uh, I was shocked on seeing this, surprisingly, but yeah, let me know your thoughts.
Yeah, well, so saw it when it was first released. I didn't actually read the article. I just saw somebody posted the grid before, the grid with the corrections on it went viral. And yeah, I just knew it was completely backwards from the beginning. And so I clicked on the comments and I was just so happy to see that like people weren't just like reading and accepting things for, because there is a lot in the community where, uh, things get said and sometimes there's like a lot of hoopla, but this one got attacked immediately. And especially as somebody, my bachelor's degree is in mathematics, my master's degree is in statistics, and I'm in the not useful category, and I'm
Yeah.
like, oh, I think I'm like doing okay, and that's my background. And then the other thing that I thought was the most funny, the thing that stuck out to me was like, not useful data cleaning. And it's like, I'm pretty positive that that's like a big piece of my job. Like
Yeah.
I spend a month cleaning a data set sometimes. And, then it takes me a couple days to model that data.
Yes, and I think one of the most important facts here is that you will see we have new tools coming up like Auto ML or even Auto DL, right? Like automated machine learning or deep learning. Have we yet seen a tool come out for automated data cleaning? I don't think there ever will be, at least for a long time, right? So it is tough.
No, I mean, I don't, that's one of those things that I don't think could ever be automated, because that's where the
Totally.
business, when I think about just variables that I've been looking at the last couple days, if I'm trying to put the amount of time that a page takes to load in my model, and I have null values, it's not like something else where I can just say, oh, I'll make null 0, because a lower number is something that's good. So those can't be zeros, and so making that decision between whether to impute something, whether to make it 0, or whether to
Yeah,
say, if this is a null, I need to not include those rows in my model. Like that's not something that can be automated. I
absolutely.
mean, I don't know, maybe somebody could devote their life to trying to like solve that one. I don't want to say
Yeah.
never, but like I'd bet my money on no.
Yeah, I totally agree with you. I think it would be impossible to build such a tool. And Shockingly, if you see here more things like artificial intelligence is like very useful, but honestly, I think it's still pretty hyped up because AI is a broad umbrella where everything else comes under it, right? So to implement true AI, it's going to take a lot of time. I mean, I believe AI is something where I mean, nowadays even linear regression is passing off as AI. I think you may have seen that joke, right? So that is something which is a bit shocking to see them use that term as a broad, like a very generic term, right, as very useful. And you have here predictive analytics coming down, right? So, yeah.
Yeah, no. So I actually cringe when first of all, there was that Sprite campaign, right? Where I think it was like, it must have been an A/B test, and they decided that
Yeah.
their new flavor of Sprite was better. And it's like, Sprite now with AI. And it's like, no, that was a hypothesis test.
Yeah.
And I've seen repeatedly people refer to logistic regression as AI. And it's like, no. And people have referred to work that I've done myself. Like I built a couple neural net models, or I spent a long time working on neural nets. And, somebody said like, oh, can you tell me about your AI models? And I'm like, it's, it's just nonlinear regression with, a couple
Yeah.
layers.
Yeah.
Yeah, yeah. So I think too, that makes me think about, we're talking a lot about workflows,
Yes.
like the data cleaning and stuff. So what does your typical workflow look like these days?
Yeah, so the typical workflow we would have followed so far, and we still follow, I think, two aspects to this. One is from the business aspect. So we try to tightly integrate the CRISP DM model, as we already know is an industry standard, right? So cross-industry standard process for data mining, 6 major steps, starting right from the business understanding, moving on to the data understanding. Then basically, I think it's known as data preparation, where we prepare the data cleaning and all that stuff. Then comes the modeling phase, and then pretty much it's evaluation, where could be multiple things, right? You evaluate your models, you evaluate the process you're following, you evaluate the results of your models, you show it to the business because they are the key consumers at the end of the day. And once all this is done, obviously you go into the model deployment phase. So I think these are the 6 main steps we follow. I also like the business science process framework. I think we all may have heard of it from Matt Danshaw, which he built some time back, where basically I think that is more focused towards the business side. And we also have things like, let's say if you're working in a product company, like recently I joined Red Hat, right? So a lot of the data science that is being done there will go as, let's say, a feature or a capability inside a product. So their things might be slightly different because it's not always just working for the business, right? It is also working for, let's say, people like us who might be using the product at the end of the day. So you might need more extensive testing there with regard to the actual product, which might be using, let's say, the data science component or a machine learning component in a very small way inside the product. So more end-to-end testing, and let's say something in the testing might break due to the model, we never know. So there, the last part becomes very important with regard to the model deployment and the usage of it, right? Basically, when we test it out and see if it's working well. So overall, I think we follow the CRISP DM process extensively. But yeah, would love to hear your thoughts around this.
Yeah, so I mean, we go through the same process as well. One of the things that I was thinking while you were speaking that, isn't really a part of the data science process, but just seems to be a reality in business is that, you work hard to get buy-in on these projects. Like when you are setting out to do a model or some type of analysis because you know that it's going to add value to the business, you sort of go
Yep.
on this tour, right? Where you'll talk to different stakeholders, whether it's operations or marketing or,
Yeah.
supply, and, you get buy-in, right? And then you can start working. And then the project can get dropped for some reason. And sometimes it's as simple as who owns it is changing hands, and they have like a different idea of the direction that it's going to take or something like that. And like, I'm actually, I brought this up because just yesterday somebody walked by my desk and they're like, by the way, that large cluster analysis that you're working on that I like literally put down a month and a half ago is now number one priority again. And so it's like there was a break and now I'm picking it back up. And luckily, like my data was already cleaned. So what happened was I did this huge, we aggregated data like all across all sources, and I cleaned it in Python. I, built out end to end how I was going to do the modeling. And then it was, well, we're going to wait for third party data. And then that got held up in procurement, as it always does. This isn't special to Constant Contact. And then finally somebody made the call, and it was out of my hands, that we were going to just move forward without the third party data, which I didn't really want to put in the model to begin with, because that would be additional bias, right? Like the match rate isn't 100%. And so if you're only able to match 60% of your customers, typically the customers that you can match are going to be the ones that are, have been in business longer or are just more reputable, have, like an internet presence. And so I'm glad that I'm moving forward without that data, but it was like, how long do you think it'll take you to turn this around? Because now it's like this, we dropped it for a month and a half and now it's a big thing, right? And the thing is I had written it in Python and I was ready to go. So I literally go in today and I'm just going through my notebook going click, 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 and I have output. And, by the end of the day, I'm looking at what is distinguishing these clusters. And that goes to show too, to what we were talking about earlier, where like the majority of the job was data preparation, cleaning, even, the like feature engineering in Python, like that was a big piece. And then literally like the part of it that's modeling, like the k-means cluster is, click, 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 click. Is that also your experience?
Yeah, I think totally makes sense. And that might even bring us to the theme of our topic, right? Like, what are the skills needed for data scientists? I mean, besides what we were just discussing, being very adaptable to changes, being very flexible to changes, and I think maybe even controlling your emotions when needed, because we have seen this happening, right? That projects, as they call it, being ZBB'd, right? Projects will get ZBB'd or just get scrapped suddenly. They may again come back, or it gets deprioritized. Management changes, so many things happen. You might be working on a really cool model on an excellent project, but hey, that's just not what business wants today. So things go out of the window in a second, something new might come in. So I think being very adaptable to changes, I think that is a huge gap between, let's say, if you are doing Kaggle competitions, or let's say learning from courses or studying in academia, right? And I think that talk which you guys had, from academia to business or to the enterprise, this is something which is very much needed, being adaptable to changes, because you never know, you might have to.
Favio did mention his temper and I was talking about it too. Yeah, no, it'll test you.
Absolutely. I think I see a question. What language are you currently working to build models? Well, I mean, again, this is also a very important thing. Depends on the problems you're trying to solve. So for us, currently, mostly Python, before being a mix of R and Python. So that's pretty much what I've been working with mostly. I'm not really an Excel guy. Like, I started off with learning Java in school, as far as I remember. Then I moved on to C++, maybe, learned Python. Then I learned R, honestly. So it was a steep learning curve, because if you know Python, right, it's easy to, pretty much the learning curve is not that hard, but R is a bit tough, but I think it's still a great language.
I don't know if, so I started learning R in 2004, which would make you think that maybe I'm really good at it, but like I'm not. I could just, I used it a lot for all my modeling, but when it
Yeah.
came to data cleaning and stuff where you had to actually know the language, I didn't know it that well. And so I don't know if it's gotten easier over the years because I know there's people like, we've already mentioned Matt Dancho, but he's a huge advocate of R, and there's people who are very passionate about R. And I know with the tidyverse, I think things have gotten more intuitive, but I never really got fully ramped up on the tidyverse. And a little
Same
over
here.
a year ago, I started using Python, and now I'll hop back over to R. Like this past year, I did, identifying seasonal customers. And so I used a time series model in R that's based on Fourier transforms instead of autoregressive and moving average terms. I'm like totally stumbling on my terminology here or whatever, but stationarity was going to be an issue. So I was like, oh, I'll go use this TBATS model where that's not a concern. And I used RPy2 to call R through Python because
Yeah.
R was going to be the right tool for that one. But otherwise, I'm almost completely in Python now. And it is the learning curve. I don't know if it's because I learned a little bit of R before I moved to Python, but Python's like a breath of fresh air. For me, everyone has a different experience.
I think it's pretty much been the same for me, smooth sailing with Python. R is a bit difficult to learn, a bit difficult to master also, but it's a good language, definitely.
Yeah.
Python is more general purpose. I think that makes it easier to blend in different things together, right, easily. So, I mean, I've been a strong advocate of Python since long. Not that I hate R or anything. It's pretty
No,
good.
I don't hate art, and there's going to be certain things that I may decide to do where it's art is going to be the right tool for the job because it's been around longer as a functional language for statistical computing. Whereas Python like was not built for specifically for the purpose of statistical computing. So R does have some advantages there. I see in the chat somebody mentioned SAS. And so I have pretty strong opinions on that, but I'll let you go first. What are your thoughts on SAS?
Yeah, my friends have strong opinion on SaaS also. So I have seen a lot of financial companies use SaaS extensively. They're still listed in the job opening. So I would say if you want to target those companies, would be good to learn. I hear the licensing is pretty expensive
It's
though.
super expensive.
That's what I have heard. I haven't learned the language personally. I've checked it out a few times. Honestly, I didn't like it. And once I know Python, I mean, it's a bit difficult to shift back into these aspects. So I would say really depends if you're going for a company. I've heard Citibank uses SaaS extensively a lot. So there are
Healthcare
companies out there.
too, healthcare, and if you were going to be a statistician, like if you were in biostats or something, that
Yeah.
absolutely uses SAS. I got a job the last time I was searching for a job. I went to a in-person interview, and normally in the screening part of the interview, like the phone screen, I ask what tools they're using, and I had apparently just not asked here. And I get there, and they're like, "This is a SAS shop," and I was like, "They're like, and where do you see your data science career going?" And I was like, "I didn't see it programming in SAS." Um, so for me, I think that like if you plan on going into the healthcare industry, if you want to be a like biostatistician or in finance, and there are jobs out there, there is demand. If you want to be able to hop to basically any industry, and you're thinking about your career sort of longer term, and you want to make sure that you set yourself up to be able to go anywhere, then you might want to think about sticking with open source.
Yeah. I totally think I would say I have the same opinion because if you know Python or are, let's say the flexibility is really good, you can do a lot of stuff out there. You can target different companies out there. With SaaS, it becomes very specific to specific companies or domains. So not a bad thing to learn. But if you already know these tools, would you need to learn this? Maybe not. So yeah.
And then, so I think it was the same person just asked about, I think it's pronounced jump. I've used it before. That's a GUI, right? Like that's, I thought that that was point and click, but maybe
Yeah.
it has functionality that I hadn't seen. I mean, that's a good one if,
Yeah, I think
you
it's
know,
from
it's like
SaaS
staffing
itself.
tries
Yeah.
mine too, you know, like if you're going to use something that's point and click, sure, it's fine. And it's not going to be difficult to learn because it's literally going to be.
Yeah. I think that brings an interesting aspect into one of our other topics, which we had around tools, right? Force fitting tools, let's say, to data science processes. One of the most important things which I've seen, there are multiple facets to this again, right? Like one is from, I would say, the C executive level or the management level perspective. As you will see, we have a lot of tools coming out, right, where you don't have to code a whole lot. It's point and click, as you were mentioning, right, with regard to automated machine learning and the whole concept of democratizing data science, citizen data scientists, all that shebang, right, where the vision is, or the dream as they paint it is, you just upload your data, click a big button, and you get the best model out there with the results, right? That is the way it's envisioned. So what happens here is uh, obviously they see the sales pitches where companies come to them. They are not the domain experts. Now we know that, right? Because they have bigger things to do. They have to run huge companies or businesses. So we can't expect them to know data science completely, but they get these perspectives that, okay, there are tools out there where you can just upload data and you get some model built right out of the box for you, right? And then they go back to the company, to their data science team, and they say, hey, why aren't we using this tool? And then those tools come into the picture, and maybe they get pushed down in projects. So you have to prove that whether this tool really works or not. That is one aspect. Another aspect comes maybe due to this, or I don't know, the whole hype around automated machine learning, where data scientists think, if we have these tools, then why are we here? That kind of a question might come into the picture. So I have seen this, or I've heard this happening across many, let's say, companies or industries where data scientists are strongly resistant to using these automated machine learning tools, right? They say we will code everything from scratch. So I think coming to these two facets, what is important here is, yes, we shouldn't force fit tools into the process, but I think we should also view some of these automated machine learning tools as maybe something which can cut down on the model development time if needed, where let's say instead of you sitting and tuning thousands of models, or let's say hyperparameters using whatever grid search, randomized search, or even nowadays we have Bayesian optimization, maybe you can use some of these tools and cut down on that part so you can focus more on the problem, on other essential things which maybe these tools can't capture, right? Like if I am building a model for healthcare, I might want a model with a higher precision than recall, right? Because if you say someone, hey, you have cancer, but they don't have cancer, that's a huge mistake. So maybe the auto ML part can't capture this, but you can maybe by tuning the model further of what you get as the output from these tools. So I think the change needs to be embraced from both sides, data scientists as well as the non-technical folks, and that would really help. But yeah, would love to hear your opinion on this.
Yeah. So, I mean, I've been doing data science for 10 years, and my experience, and of course the packages and the libraries and the functionality is coming out a lot faster now. Like it's coming out at warp speed. But my experience has been that every time something new comes out, it makes my job a little bit easier. And every time my job gets a little bit easier and certain things take a little bit less time to do, because even feature engineering and data cleaning is, still a big part of the job, it takes me way less time than it did 10 years ago. And so I think that anytime that we have tools that are going to make our job easier for us, it allows us to have more time to focus on higher value priorities and initiatives, right? Like AutoML, maybe we won't be building retention models or acquisition models or things that are very standard that, most businesses have. But then there's the interesting models, the things that are like the real out of the box problems where you have to do some research, the stuff that gets you really excited, and that's why you're a data scientist. Like, those problems aren't going to be automated. No one's going to come up with some like weird, obscure automated model for a problem that's specific to your business, outside of the models that we see everyone having. At least that's my opinion. That's my thought. That's what, that's sort of where I think it's going to go, is that the job's going to get a little bit easier, but we'll have the opportunity to be more of a thought partner, a consultant to the business, and it'll open us up to work on even cooler projects. I'm like 100% positive.
Yeah, I think that totally brings to the point of creativity and innovation, which we had also mentioned, right, as the key factors for a data scientist to really succeed, because not everything is a run-of-the-mill supervised or unsupervised problem. Because right now these tools just focus on that. You have a fixed number of labels, you have some data or some features, they might help you just generate some new features and build that model, but not everything is that black and white. It is more, I would say, ambiguous, and that is where we really need to put our thinking hats on and think, hey, can I focus on this problem in a completely different way from what people are thinking it is? And that is where I think it can't be automated, at least for a long time. So data scientists shouldn't really worry about that. Yeah,
because even, to be honest, when I started thinking about how to determine customers who had seasonal usage patterns, right? Because it was just one of those things where it was like, man, we know we must have customers that are seasonal. How do we detect them? And my first thought was, maybe I'll use some type of quality control. Like, if our customer's behavior looks like this, then, when you're above the bounds or below the bounds, maybe that's your high or low season. And then you look at some of the data and you're like, nobody's pattern looks perfect, and you start exploring and thinking, and, sometimes you do spend a couple weeks just not fully focusing all of your time on that, because you can't just sit there staring at your computer. But, it's the type of thing you're thinking about as you go to bed at night, and you're thinking about in the car on your way to work. At least that's how I am. Like, this stuff really excites me. And if somebody gives me a problem, like, I'm gonna find a good solution for it. It may not be the best solution in the world, but I'm going to come up with a solution for that problem that's like really reasonable, and works well with the data. And creative innovation.
I think totally makes sense. Yep.
All right, let's check out some of the other questions. Did you already answer the what language are you currently working on? So you said Python typically, and then, have you ever tried Julia? I haven't. I need to download that and try it. I haven't even looked at it.
I have just checked it out. I haven't ever coded in it, though. I hear it's interesting. It is nice, but how is it different from Spark or Python? Well, Spark is a framework on its own. You can use Spark APIs in Scala and Python. I don't know if it's for Julia, though. If Julia is there, I've seen, I think, Python R and Scala being used most extensively. So if you want to use Spark, basically the idea is if you're working on big data, right, and cutting through all the hype again, big data is basically data which doesn't fit in the RAM of your computer. So if it's bigger than that, go for Spark. Otherwise, I mean, if you want to try out, then great. Otherwise, I mean, you would just be wasting your time, right? If you can load it up and build out models or whatever be it. Obviously, yes, if you envision your data becoming bigger over time and you want to scale out, then Spark might be a good option. And I think PySpark, a pretty good API. That is what we have used. Many people have used in Scala also. I hear it's more efficient from a performance perspective, but hey, at the end of the day, if you are using Python, PySpark works pretty well for us. That is what we have seen. So yeah, I mean, Julia, I hear it's good. It's picking up some steam, but I think still user adoption is not anywhere near Python or R. So yeah, that would be my answer on this.
Yeah. And back to, because you were talking about big data for a second and how it's only anything that's bigger than what fits on your computer. And, you know, I think that's harmful to a lot of people because I, for a long time, like thought I was missing out on something. And then I got into Hadoop and I started querying there and I was like, wait a second. This like isn't, it's not that crazy. And it's not, I don't know. It's like just not so sexy. And like, I mean, it's cool. And if there's something that's in unstructured data that we want to go up and grab, I can bring it down onto my local machine if I aggregate it first, of course. But like if we decide that that variable is useful, then it's just going to go back over to the big data team or to BI, and they're going to set up a feed to get that relevant. You know, it might be that somebody is typing in something on a, I don't want to give away what's in our like big data environment, but like we've got a lot of data there and a lot of it is block text. And if, you know, we find that certain people are mentioning the same word, it's like, okay, well, let's pull a variable into the data warehouse that's just like this person has mentioned this word or the number of times that a person has, you know, either yes, no, they have, count of times that they've ever mentioned it. Like, you know, there's a bunch of ways that we could think to feature that, but feature engineer that, but like it'll absolutely come into the relational database and then I'll query it just like I query the rest of the data.
Yep.
Has that been your experience as well? Like if you find something in the big data environment, do they make it available for you in the data warehouse or?
Pretty much. So the initial part of a lot of our projects involving big data was, since we are unable to run the regular SQL queries on a normal relational database, we are still running the same SQL queries, but on the big data warehouse at the end of the day, and then working with that data, building models and so on. But one thing was, yes, when Hadoop came out, I was one of the first folks, I think, who got into the MapReduce aspect of it, right? Like I wanted to know what the hell is going on with MapReduce and running these kind of programs. And I saw that, hey, for even a word count, you have to write these huge programs, right, called the mapper and the reducer. And that really put me off because I think even for a normal SQL query, as you might know in Hive, at the end of the day, a MapReduce jobs runs in the backend. So that's like you have to do so much stuff just for a simple thing, just because your data doesn't fit in main memory, right? And then Spark came out. I think that was a welcome change because a lot of the syntax is like pandas. You can chain operations together and you can get things done in a short amount of time. But based on my experience, if you talk to a lot of people, most of them don't like Spark. I mean, it is great, but errors are really hard to debug. I mean, if you have one small error happening in a pipeline, let's say involving Spark, it's really difficult to debug. So things are improving, but yes, I mean, big data has honestly been hyped up a lot than what it
I was scared of it, and then I got in, and I was like, "Oh, it's just data."
Yeah, and then there came this thing called data lakes, right, where you dump all your data. And if you may have seen my recent article, and even I think Forbes published it, that data lakes haven't been able to deliver the value they were meant to be. So I guess what's happening is people are saying, hey, these companies are building data lakes. We have to get on the big data bandwagon. And then there's no value. You're just having some data repository and without any
Unless
strategy.
somebody's going to go and feature engineer that stuff so that it's
Yeah.
like organized in a cluster in a way that's usable, or it's
Yep.
brought into the relational database. No one's going to use. It's gonna be like stuff that you throw in your attic that you tell yourself you're going to use someday. Like you don't.
Absolutely.
That's my analogy. 2019. That's my new analogy about data lakes.
Yep.
So I just saw, who was it? Sonia asked about SQL for a data science interview. And so I'm just going to put this in here. This is a link to my SQL browser. So I'm currently creating a SQL for data science course. But if
Wonderful.
you're looking to prepare for data science interviews, just go to Medium and type SQL, and there'll be a bunch of articles on interviewing for SQL. Go into my browser. It's free. It's just on GitHub. The data's right there, and practice your joins, your where statements, your having statements. Maybe write a subquery and just practice a little bit. So I'd say use the data that's in my browser and go grab an article off of Medium and practice writing joins and stuff.
Yeah, I see another question around data visualization, and also even in the chat, I think around, same question, tools for data visualization, and even D3, what is our, I think, opinion on it. So for me, I think, again, since I'm working as a data scientist, it's been mostly Python. So we start off with standard Seaborn, Matplotlib. If we want interactive, maybe Bokeh or Plotly, that's what we have been using. D3 we have used, though I have never coded for my company using D3. I have done it on, let's say, if I wanted to experiment and play around with it. It's a pretty decent framework if you want really nice, clean, concise visuals. You do have to write some amount of JavaScript there, though, and it's again not an easy learning curve with D3, because errors in the front end again are very hard to debug, right? If your visualization is not aligned properly, something is going wrong. It's not as easy as Python in the back end. So D3 has a steep learning curve. If you really want to master it, you will have to persist with it. That is all I will say. And and for R, I think ggplot is pretty good. Base R is also what I've used, but I think recently a lot of new packages have come in. I think Favio had put an article sometime back. I haven't used a lot of R though since Tidyverse came out, so I wouldn't be the best judge on that, but that's pretty much what I use. What about you?
Yep, no, similar. So it depends. If I'm in R, then I'll use ggplot. If I'm in Python, I use matplotlib. Seaborn, I haven't, to be honest, I haven't built any really cool. If I need something to be, something that an end user can play with and slice and dice, I'm probably gonna just go into Tableau.
Yes. I think
Point and click and pass it off.
Yeah, because it's all about what you need at the end of the day, right? It's not like, maybe if you're building a project in the university or somewhere else and you want to showcase some really cool skills, that is great. But in the enterprise, again, this is one thing, right? That what are the skills you need? You need essential skills for data visualization, but basically the visuals should be clean and communicate what they need to. You don't need too much fancy stuff unless it serves a purpose, right? At the end of the day, people don't need to see a lot of buttons or whatever things to click on unless there's a need for it. And I mean, you have tools like Tableau which can do the job for you pretty easily instead of you coding it maybe with 10 more lines of code. So I agree on that.
Right, and it depends on exactly what you were saying, the business needs. It's like, do they want, because I'm not really building dashboards. But so if somebody wanted a dashboard, that probably wouldn't be in, that would be more in the general analytics, that would get that work. So most of the visualizations that I'm making are, I just built a model. I need to communicate this to the business in a way that they're going to understand. So I'm going to go into the database and I'm going to pull customers and show what their score was and what their attributes were and why the model placed them there. And I'm going to show some like bar charts or just, like nothing special, but something that the business can very clearly look at, understand, get, what my model is doing and what the benefits are. So I'm not building out like a dashboard or although I'd really like to learn how to use like Shiny or something, even though I just said that I'm
Shiny is pretty
Python,
cool.
but I want to use Shiny and Plotly just because they're just,
Shiny is pretty cool, I think, because I think that is somewhere Python is lacking. They don't have a framework like Shiny as far as I remember, unless they have built something around that. Because I remember for some of our projects, everything was done in Python, but because they wanted a quick and a nice interactive user interface, they used R Shiny for that. So I learned it during some courses online, but that was it, right?
Yeah, I did the workshop at ODSC East last year.
Nice.
So, I've like played with it. I know it's fun. I haven't like really dug my teeth into or used it to deliver something in business. Have you built Tableau dashboards with R or Python? So what my workflow would look like there is I'm pulling my data into R or Python from the database. And then I typically export a CSV out and then I pull that CSV into Tableau. And so Tableau can hook up to big data environments as well. It can basically hook up to anything. Like Tableau, if you can think of it, Tableau probably hooks up to it. But it wouldn't, but not to like a programming language. How else are we doing? So we only have like 5 more minutes left, guys. We'll try and get.
Yeah, we have some questions around, I think, data science. Both of you have bachelors on fields other than DS. What are your thoughts on, okay, MSDS offerings from university? Should we actively pursue that? Or basically, can we learn it on the side, maybe something like that? Some people are even asking about, I think, probability and stats for studying data science. I think we can club these questions together. So yes, my bachelor's was in computer science. Obviously in school, I hated math to an extent, but then I think from the, I don't know, 9th or 10th standard, I started loving it because that is where statistics came into the picture, I think, and I used to love it. So I think probability and statistics, definitely you need to know it because otherwise you will not know even the very basic model, like let's take logistic regression. You wouldn't know how it's really working behind the scenes. And when you're working in the real world, just let's say a model.fit or predict is not enough, because if something is not working, that is when you need to know why it is not working, or
confidence intervals are everything.
Confidence intervals, right? So absolutely, like Kristen is saying, confidence intervals. Pretty much, you need to know statistics and probability. Calculus, again, I would say if you are learning machine learning, know the basics with regard to how it's being used in machine learning. You don't have to sit and solve really hard integrals or differential problems, right? Because time is everything at the end of the day. With regard to programs, I think yes, because I had some subjects around artificial intelligence, neural nets during my bachelor's. I loved those topics, though that time we didn't have something called data science, or even AI was kind of not practical as it is nowadays. So I loved those. So in my master's, I dived deeper into data science. It wasn't still called data science then, but we had data mining, we had machine learning, all these aspects. So I loved learning those, trying out different things. I think even pandas, scikit-learn, I remember maybe I was the only one who did that, use those packages to do a project. Then a lot of people were using R. Even my professor said that, hey, why don't you use R? I said, hey, there are some really cool things in Python. I loved Python. I'm doing it in Python. So they were on board with the idea, and it worked really well. So yes, I know nowadays a lot of universities across the world are offering MS in data science. Some are even offering something called Masters in Computer Science and Data Science. So for me, I would say that if you want to go for a master's degree, I will say time and again that, do you have enough time to invest in it? Do you have enough money you want to invest in it? Because a part-time program, let's say along with when you're working, it becomes difficult, it becomes tough, because I have done some part-time courses in general when I have been working, and it's not as easy as when let's say I'm in university and I can stay up late all the time and just keep learning, right? It becomes difficult. So I would say if you want to go for a full-time program, think about the time, the effort you need to spend, or if you're going for a part-time program, can you really do it? Would you really need to do a MS in DS? That's a tricky one to answer, but I mean, it might help you definitely to go more towards a data science job. But Kristen, maybe you would have a good perspective on this, considering you have helped people basically jump into data science careers. So I'll let you take that one.
Yeah, so I mean, just like yourself, I don't have a degree in DS because I've been a data scientist since before it was called data science.
Yeah.
And the program, the first data science program came out in 2013. And so I was well done with all my schooling before then. And so honestly, I haven't, in terms of hiring, because they're so new, I haven't seen a ton of resumes yet come through of people who have finished these data science master's programs or bachelor's programs, because literally, in 2013, when the first program came out, there probably wasn't a lot of people yet, and now it's getting popular, and I think it's in the next couple of years that I'm going to start seeing the resumes that really have data science degrees on them. I think the important thing to think about if you're going to get a degree in data science is just to make sure that it's actually going to cover the things that you're hearing about here. Like, you're going to learn about, make sure it's, going to show you extensive SQL and cover, how to access a big data environment and how to, get at data that isn't in a relational database, that it's going to teach you some Python or some R, that it's going to go deep enough into statistics and probability to be useful, and that it's going to, cover enough calculus and linear algebra to be useful. I mean, if they have a well-rounded data science program that covers all those things in significant depth, I think that there would be tremendous value there. My concern is that you're not going to get, enough calculus, that you're not going to get enough of, I just don't know, right? That's not me saying anything negative about data science programs. I'm just saying, do your research and make sure that, the level of statistics that you're going to get is going to go beyond, this is the normal distribution. That's all.
Yeah, just be careful and do your research, because since these are hyped up areas now, a lot of institutes are cashing in on the hype, sadly, and offering programs which don't live up to the potential. So basically, don't be in a situation where you're disappointed later on. I think that's the main thing.
All right, awesome. Okay, so I have somebody asking about online courses. I do have a good article on the online courses that the community recommends on my blog, so you might want to take a look through that. Do you have a favorite MOOC?
With so many MOOCs coming out recently, it's tough to say. I honestly started with Andrew Ng's machine learning course, which was really great. I then did the data science specialization from Johns Hopkins. I think
Yeah.
they used R completely there. That is where I think I really got into R, so that was great. Then there is, I think, I hear applied machine learning with Python from the University of Michigan is a good series of courses if you really want to get hands-on. So that's pretty good. And nowadays, a lot of things have come out. I think mathematics for machine learning or data science specialization on Coursera, that's pretty good, I hear. And yeah, I mean, just go out there, check out things, and if things look too hyped up, basically don't go for it. Or if you basically take a course, I would say first audit the course. If you think it's worth doing, you can even pay for it. That's the best way to go about things. And just don't do a course for the certificate. Doesn't really help in the long run. That is what I would say or advise.
Yeah, because at the end of the day, you're not putting those certificates on your resume, because companies don't really value those. You're doing it for your own learning for yourself, and just like DJ said, I also audit courses before I decide whether or not I'm going to pay for them. I'll be auditing like 4 courses at once, and then finally one will catch my eye, and I'll sign up for that. Um, all right. So thank you so much for joining us, DJ. This was an awesome chat, even though we didn't have our beloved Favio here.
Yeah, I think we got a lot of questions. I mean, it's a bit overwhelming, but I'm sorry if we couldn't answer all the questions. Just maybe reach out to us. We'll do it on LinkedIn or somewhere if needed.
For sure. Okay. Thank you very much for joining us, guys. I can't wait to see you on the next Data Science Live. Oh, next Data Science Live, by the way, is going to be January 23rd, and we're going to be having Kirk Bourne. So,
Oh, he's an awesome guy.
Yeah, right? I'm really excited. Okay, so thank you very much, and I'll see you guys all soon. Thank you.
Absolutely. Thanks for joining, guys. Take care. Bye.
Bye.